Yeah, I might be a minute late. What's good, y'all? Yeah, I pushed it back today because I have an OS exam tomorrow. So, I've been trying to study for that. But yeah, none of that's an excuse to not stream, so I'm still here. Yeah, our first exam is on like the different locking structures, and then like the usual like concurrency control structures, and then like some basic scheduling stuff. So yeah, it should be a pretty good time. I just need to like get through a little bit more of it and just like do a couple more reps on like practice problems to be fully confident. Yeah, so unfortunately this means I don't think I have the mental capacity to like fully solve the MIDTERM stuff today. So we're actually gonna push this down a little bit more. Let me pull up my big pile of things to do. Actually, let me take a snip of it and then annotate over it again. Okay. I was learning basic semaphores just now. Ooh, good stuff. Yeah. It's crazy that semaphores were like, I guess, created by Dextra as well. Like, the guy actually just did everything. Yeah. So we got this big pile of stuff. I think what I want to implement right now is going to be either this pile here, or I guess like these two. Or I guess let me slow down. We've done these already. We've done these already, and we've done bitwise and. We've also done equals. Yeah, we've done addition and subtraction as well. So what I want to do, I think, will be it'll be either these or like these two. I think I'll probably do these bitwise ones because they seem a little bit less awful to do. Logical and illogical or seem kind of annoying because I also have to deal with like short circuit properly. Yeah, I think that might make more of a mess. So yeah. Learning object-oriented programming in C++ this week. I think the biggest thing is just like, I think just if you're familiar with object-oriented programming in general, you can kind of like port that back over to C. Like if you're familiar with it in Java, because Java is, I guess, the language of object-oriented programming. So I think at least understanding what it looks like in Java might help a little bit with understanding how that ports over to C++ after that point. But that's not to say you have to like write your C++ code in an object-oriented way. Like you can still use objects and I think not necessarily do it in an object-oriented way, if that makes sense. Syntax barrier? Yeah, fair. Yeah, that's more just like learning C++ then for the most part. Just if you can like make a one-to-one mapping of things, or at least as close to one-to-one mapping, I think that is largely sufficient. Let's see. I kind of don't want to implement any of these, honestly. I guess most of the trouble will be in the back end, so... let's see. What would be interesting? I guess logical not could be interesting. Or I guess logical and bitwise not, we'd have to... Logical not will be annoying. Bitwise not is pretty straightforward, I think. How does LLVM represent some of these, at least? Is SQL Interpreter easy compared to the other ones? I think it's about the same. I think SQL is a little bit more cut and dry, though, so it's less, I guess, annoying to do. Like there's less like random rules. It's kind of just what you see is what you get. Whereas like Python, there's like all sorts of different internal interpreter resolution stuff. Whereas like SQL is literally just what you see, I guess. Okay. I guess we could go to Godbolt. Let's take a look at some of these operations. Okay. Let's just start with return 0, because that's always good to have. I equals not 1, I guess. Not 1, 2, 3, 4. We can do like this. That's like, we can do it like this to block the fold, I guess. How long will stream be? Not really sure. I guess just however long it ends up being, which is, I guess, not really descriptive. I'm aiming for like half an hour because I do want to study, but yeah. There's no like, I'm trying to keep it towards the short end at least. Okay, how do these look? Wait, XOR? When did XOR show up? Wait, what? Wait, that's crazy. What? That's crazy. Okay. Okay, well, what is not? What is logical not? Oh, it's also an XOR. Wait, whoa. Wait, that's crazy. I didn't think of it like that before. So to bool, this one is... Okay, so this turns that into a Boolean value, and then we flip it, and then we sign extend. Does XOR just flip? Oh, I see. Okay, that's really cool. I didn't realize that's how it was implemented, at least. That's really cool, actually. Holy shit. Wait, my mind is blown. So let's draw this out because I genuinely think this is like way cooler than I thought it would be. Okay, so we have like, let's say like just some value here. Let's do like 9. So when we do logical not, what happens is we take this, first we turn the 9 into a Boolean. So this becomes, or I guess like, yeah, so this as a Boolean is just 9 not equals, yeah, we can just do it like that, not equals 0. So then that becomes true. And then we XOR it with true. So then true, XOR, true. Well, I guess we could use the symbol, I guess. Is that XOR? Yeah, or damn it, wrong way. Okay. My notation is a little bit rusty. So we XOR that with true, and then we get false here. And then optionally we like 0 extend it again. I can't write, holy shit. OPTIONAL. 0 extend. And this becomes like 0. Yeah, that's really cool. I've never thought about it like that, actually. That is a really cool implementation, I guess, of logical not. So everything is XOR, which is very convenient, actually. And then bitwise not is straightforward. We just XOR it with sign -1, which, if you think about how that looks, it's just the sign bit is 1. So I guess we have like 8 bits. Let's just draw this out. So this is the sign bit. So this is like, I guess 1, 2, 4, 8, 16, 32, 64, and then -128. If you don't understand why it's -128 for a signed number, look up 2's complement. That is basically how negative numbers, or I guess signed integers, are implemented in most places. Yeah, so -1's representation is just a 1 and the -128 because it has to be negative. And then if we set everything else to 1, that gives us 127. So the total is -1. And if we XOR it against that, then we just flip every bit, basically. How is the XOR trick better than a comp against 0 plus C move? I'm not sure actually. I'm guessing because in the backend that reduces down to oh, actually no. I guess there's still a compare there anyway. Yeah, I wouldn't be surprised if that's what's happening. Compare against 0. Let me think about this actually. I suspect a compare again. Actually, yeah. Actually, why isn't it faster just to do equals 0 instead of just like this? This seems silly to me. There's probably some scenario that it breaks down for, at least, that I'm not thinking of. Let's ask ChatGPT. Lang's implementation of logical not inverts uses XOR. Why not just compare? Oh wait, I understand now. I think I understand why now. Because so logical not is supposed to be run on just booleans, right? So it's faster to just straight up flip. But what's happening here is that we still get this compare anyway because we're just going from like int down to bool, I think. And then back to int here. Whereas if it's just bool to bool, we can save the comparison. I think that's what's happening, at least. I could be wrong. As in, like, if we just directly compare against 0. Yeah, if we just directly compare against 0, that requires a some sort of conditional branch. Actually, wait. I don't understand the assembly level. x86, 64, cheat sheet. Is there just like a conditional set? Or how is that implemented? Oh yeah, there is. Wait. Huh. Wait, this has become very interesting, actually. So if we just like bool this. Oh, bool doesn't exist. Yeah, I forgot. Okay, let's see what happens with GCC. Yeah, I'm curious. I forget how to change the IR viewer. Oh, that's a thing? Wait. Wait, that's nuts. Okay, let's check Cling again. This is the only one I can actually view the internals of. Yeah, this just does the comparison, regardless, I guess. Right? Wait. Oh, wait, because this is an int. Whoops. Not true. I guess we could do 0. I don't know. What the fuck is it doing? Wait. Wait, what are we doing? I guess booleans just don't exist, so like fair enough. But that's really interesting actually. If I import C boolean stdbool. It's still the same. Interesting. Well, well, let's chat then, I guess. Why does Kling's implementation of logical not use an XOR instead of just comparing to 0? Oh, I guess that makes sense. MSVC makes a branch? That's awful. That is truly terrible. what is wrong with Microsoft? Actually, I didn't say that. Microsoft, please hire me. But yeah, that is an interesting design choice. I will say that much. Oh. It always generates comparison with 1. Or Jensa not equal comparison to turn it into a bool. Ready for Fang? Yeah, I'm hoping. Yeah, but yeah, I don't know. I think it's correct that like it should just be faster to, I guess, compare straight with 0, right? It should just be faster. I don't understand. Unless they're like reusing code or something. That's really interesting. I wonder if this is even like a missed optimization or something. There has to be a real reason for this. Playing logical not using XOR. Oh, wait, what? Yeah, maybe GCC does do that. Alright, this is with O0, right? Or should be with O0. What happens with O3? Okay, actually, that's a dumb question. It'll just fold. Yeah, okay. This is very interesting, actually. You'd expect it to not use XOR. You'd expect it to just directly compare. Huh. So that's really interesting. I don't have logical operators anyway right now, so I guess I can't really implement it, which is the really funny thing. But I can definitely implement bitwise not. This one I think definitely makes sense to just XOR against one. Dash S. Or wait. Wait, this just generates assembly. GCC QIR Gimple. Gimple. Oh, okay. Bet. Oh, let's switch over real quick. Is this the Gimple? No, it's not. What's good, Jose? I'm doing alright. Are you doing alright? Hopefully you're also doing alright. Add new... Huh? Oh, wait. Where? Sorry, where do I do this? Ah, wait. GCC tree RTL. Oh, okay. I see. Gimple. Okay, there we go. Figure it out. That's really cool. Oh, this doesn't let me highlight things. Tree dump. Yeah, okay. So this is what we want. Yeah, this is just a... okay. Raw dump? Oh, that's gross, okay. Huh. Okay, so what if we turn these back into ints? This is just turned into staring at... this is turned into staring at Godbolt stream, which is really funny. But this is like actually really interesting. Yeah, this is just a equal 0. Huh. Wow. Asm cons. Where do I throw that? Seems like reasonable at least. Like this seems readable at a glance. What do these buttons do? Gimple tree box. What is this button? Oh, poo. Uh-oh. Why is it, you know, why is it, okay. Perfect. This is, this might be less readable, I fear. Interesting. Yeah, okay. Yeah. Let's go back to something reasonable. Okay. I think I should probably just implement it as equals equals. Or like just a direct comparison instead of the XOR trick. I think the XOR trick is like a little bit awkward. I think the reason that LLVM does XOR then is probably just because like it just treats logical not as convert to Boolean, run bitwise not, and then sign extend it back, I guess, or optional sign extend it back. I think that is what LLVM is doing, which is why it does that really convoluted thing. This also means I probably have a chance to just do an optimization here by hand, right? That's an interesting note for myself. I'll be sure to write it down nowhere and completely forget about it when I actually implement it. But what we can do right now is we can do bitwise not. This will be interesting. We can do that, and we can do XOR, because XOR just uses, or bitwise not definitely uses XOR. I think maybe in both implementations actually. Nope, it just exists, I guess. Fair enough. Oh, not just exists. Wait, not just exists. Wait, what? It's not faster than XOR. Interesting. Okay. Interesting. Okay. So I guess we should just use XOR for this then. Look at throughput for instruction sequences. Interesting. Usage of XOR for booleans literally just switch the value. Yeah. I think that makes sense. I think I will codegen as XOR and then optimize to not, potentially. I think that is probably the smartest way to go about it. Anyways, in terms of what I'm gonna do then, I think for now I'm gonna implement these two, bitwise OR and bitwise XOR. And by implement, I mean I'm going to make operators for them, and I'm gonna add them to the parser, and we're gonna call it a day. Yeah, because I do need to study, for better or for worse. And I promise I'll fix the mem2reg issue eventually, but that's something I care about a little bit less immediately. Yeah, it makes sense that XOR is used to flip. I'm just surprised that we just canonicalized down to XOR. Although I guess that makes sense, just because like canonicalization. We can like reduce the instruction set a little bit, I guess, with that. Oh god. Okay. Anyway. Okay, let's start adding these new operators at least. And by new operators, I mean just XOR and OR. What does OR turn into? Let's switch back to Clang. Where's Clang? There's Clang. XOR also said ZF? I see. Interesting. Let's see. LVMR. Okay, so we just have a straight up OR, which is nice. Okay. So let's add OR and let's add XOR. I think we can kind of have both in here at least. Right? We can add both here at minimum. Let's start with the header, because this is where everything lives. Eee, what am I doing? Okay, we have OR and XOR. I'll add not next time maybe. Or I'll add it now actually. It should be, I guess like, how am I distinguishing these? Is it not and negate? I guess. No, negate is different. Surely we study OS? Yeah, soon. I just have like one more slide deck to go over. It's just the final slide deck. I don't think there's much else to study, but yeah, that's why the stream is supposed to be short. What kind of roles and companies are targeting for this? The big one's Apple and NVIDIA, I guess, because they have very large compilers that need work. Yeah, just in general, places I can work on compilers. Preferably like the LLVM toolchain in some capacity. What do we call this? I don't think we call it just not. Should probably add like a separate logical No, we're not adding a separate logical actually. Let's make these just bitwise. I guess like bit. And then XOR is always bitwise, right? It looks like it always is. Yeah, I guess it's redundant to, I guess, make a logical. Is there a better way to name these? Probably not. Do they hire entry level? They hire some, yes. It's definitely not going to be easy, but I guess it's at least worth a shot. Yeah, let's just rename these, at least. You know, instead of doing real work. This should be bitwise. Okay. This is bitwise. We need bitwise OR, which is height, and we have caret. OR, this is XOR. This is fine. And then we want tilde. Okay. That's all of those. We need to change some things here. Bit shift. Yeah, I'll do those next time. I think I need to like reason about those a little bit more. I guess not really in the front end, but I would like to stretch this out to cover the rest of my finals pile. Rotate is crazy work. I'll think about it. I probably won't add it because truly why, but it could be interesting at least. This is bitwise not. This is tilde. And then, yeah, I don't think any of the unary operators have a specific LLVM instruction, so that makes things a little bit less awful for me. Okay, I think that's, oh wait, we need to make these not and real quick. Or do I need to distinguish that? what does this look like? Interesting. What are you doing? I'm adding more operators to my compiler right now, so we can do more interesting things with numbers. And I'm drawing a lot of inspiration from LOVM at least. Okay, I guess that actually makes a lot of sense. You can just do a compare. Yeah, we'll need to refactor a lot of stuff once we add logical comparators, but that's a future issue. Maybe we don't add the word bitwise for now, then, actually. Yeah, we could do it like that even. Yeah, actually, that sounds quite nice. Okay. That's all fine. That'll be fine in a second. There we go. Those don't exist yet, that's fine. Let's add those real quick. When you have a logical or /and with multiple goals, you can convert it to bitwise. I see. Yeah, I guess that makes sense. That seems pretty reasonable. I guess booleans will be just like hidden here at least because I don't want to implement them in the front end. Operator. This is where we are. So we have and, we have or, XOR. Or, we have XOR. Okay. And we need to add these here. I think that's everything. Okay. Alright, bitwise or /not /XOR operators. Okay. So let's just add it to the parser real quick. We're gonna have to add a couple more layers to it, but that's no big deal. We start here. We don't need to refactor much. We need to add layers here. We want bitwise not. But we actually want to steal this. This is tilde. And then we need to add more layers again. So if we go back to this snippet we have, we need to add a level 9 and a level 10, I guess. Yeah, that should be fine though. So let's go down. 9, 10, okay. So we have bitwise, XOR. We might as well just steal this, to be honest. I can steal this line. XOR, I guess like caret is the word, the character, the word. This will have an expert 8 in it. This goes below these now. This is just an expert 10. Yeah, that makes sense. It just occurred to me that ternary is not even that bad to add. It might just make a mess though. Let's steal this again. This is a 9. And this is an 8. And then Pectoral Star, this is a X per, or no, bitwise XOR. Okay. So 9 is done, we need to add 10. And if you're wondering where these numbers are coming from, it's from this table, which is like on, I think it was like CPP reference, or just like the big C reference. There's a table with like operator precedence, and I'm just using these precedence levels here as the numbers on here because it's easier for me to track that way mentally. Okay, so we wanna steal this. 10 is just OR. So we can change this to pipe. And then this is a OR. It's a 10. Okay. I think that's cleaned everything up. Okay, so now we need to add these to the actions real quick. I think these are... something is wrong with the precedence order I've put here, but it doesn't really matter. We can steal this, I guess. And then we want 3 of them, I think. This is 4. That's fine, but this we just changed with OR. Alright, okay. This should be XOR? Yeah, okay. And then unary bitwise not. That's really ugly. But that's fine. This one I think we should handle like oh wait, that's up there? The oh wait, no, this is exactly as expected. Okay. Okay, so it turns out these actually do respect an order. So let's just steal this. So XOR, OR, and add, subtract. Those are higher precedence. So then this goes here, I think, roughly. Okay, let's steal all of the body here. This should be bit, or I guess it should be not, I guess. We'll refactor it later to not suck. Get it? Because not. Yeah, so that should be good. I don't think we need to change anything in the AST or the HIR. I think we just need to change HR to MIR because we need to handle one new case here. Yeah, the other ones should be handled neatly. So it's only the unary that is strange, at least. So we need to make an XOR, and we need to XOR it against -1. So front end. Is this all front end? Wait, this is all front end. Why do I have this? We have let's add the break so I don't forget about it. Can I jump from this? What? Huh? Am I going insane? This is -1. Yeah. -1. -1. Why doesn't that work? Let's... Why can't we jump to this? This doesn't make sense. Why isn't this working? I guess why isn't it letting us do this? Should be defined in here, right? Yeah, so it definitely exists. So then... What? Do I need to change anything in here? I shouldn't need to. Yeah, that doesn't make sense. To protected scope? What? That doesn't work. Huh? Oh, interesting. Wow, that's nuts. Wow, I did not know that's a thing. Okay, so this initializes values, which is not allowed, I guess. Wow, I never knew that was a thing. That's really crazy. Okay, so let's do literal, I guess like yeah, we can just call it that, I guess. Right, is that what type this is? Yeah, or value star. That, we can do literal like this even. And this is also why you attach the star or the ampersand to the variable name, by the way, instead of the type. Because if you did it, if you attached the star to the type, then you would have an issue here because, yeah, because only this first one is a pointer in this. Whereas if you attach it to the variable name, it's very clear which one, or it's very clear what each of these is. Specifically whether it's a putter or if it's not a putter. Okay, so we have that, and then we want instruction binary op, I guess. And then, yeah, so we want unique footer. Yeah, okay, so we can do that. Okay. So we want this to be literal. This should be bin op. This is now literal. And this is now what is this now? This is where does oh, I see, that's where value comes from. Let's set this to bin op get, I guess. And this we want to move. What are you compiling? My plan is to go from a subset of C down to x86-64. Yeah, that's what I've been working on, at least. Okay, this seems reasonable. So now we can adjust all of this stuff, at least. We can even like move some of this out, at least, just like if bin op exists. Right? It's not what we want to do. Or just like even if literal is not null pointer, then we have to do a thing. The only other unary op we have is logical not, which is gonna be a train wreck regardless. So I think we can just leave the duplicative code for now, at least. Okay, so we have -1 there. This should be XOR. What are you compiling? I've already explained that. Compilation is the process of, I guess, translating code from one language to another. So, yeah. Yeah, this rest of this seems pretty reasonable. Literal value. Maybe we could change the order on this, not that it matters. I guess reasoning-wise, it makes sense. Okay, I think that's good. What language? C. As in like a limited subset of C. But I'm writing this in C++ if that's what you're asking. Okay, I think this should just work out of the box then. I should make tests real quick. And this should build. If it doesn't build, I will be a little bit annoyed, but I guess I can't be that surprised if that happens. Yeah, this always takes forever. Not that I'm surprised, but... okay, that does what we want it to. Or... we don't want it to be failing this test, but we aren't surprised that it fails this test because I haven't fixed it yet. So let's add things to the test real quick, to the binary op test. I guess we have we have more than just binary ops here now, so it's a little bit misleading, but unary not, I guess, or unary bitwise not A. Okay, we have bit and let's make this OR, XOR as well. Let's do that. Are there any other interesting numbers we could do here? Guess we can do like what is interesting here? We could do like 12 and then we can do 3. And that should give us like 15. Because there's no overlapping bits there, so we should just add them. XOR, we could do something interesting, I guess. 31's a good number to work with, I guess. We could just do -1. Right, and then this should just like flip it. Actually, we could do 15 and 4. Okay. So let's run the regression test generator. Test. Oh, wait a second. That's interesting. Okay, so that doesn't do what we want it to. That's really interesting. Why doesn't it do what we want it to? Did I mess up the parser somewhere? Let's see what it has at least. Oh, okay, so it cuts off at bitwise and. Okay, so what's going wrong in the parser then? These actions should be fine. X per 8. Oh, wait, I see. Figured it out. This should be 9. Alright, 10 goes to 9, 9 goes to 8, 8 goes to 4, because that's how math works. Alright, let's rebuild it again. This should be good then, after we regenerate. Yeah. So I wanted the stream to be half an hour, but it appears that we've hit an hour by accident. So, whoops. But it was worth it. I'd say it was worth it. Let's just keep rebuilding, because I guess why wouldn't we end up rebuilding again? Make a test. Okay, so that passes all tests now. Let's just check the output. Okay. Yeah, so we have this pile. That looks like it didn't generate unary not. Why didn't it generate unary not? Or unary bitwise not? Oh, I forgot to include it. This should be good then after this. Let's regenerate tests. Oh. Because these both use different binaries, so I actually have to make both, which is kind of funny. But yeah, if we look here, just go up here. Yeah, there's this extra unary knot. Okay. So now if we look at the test. Yeah, okay. It has unary bitwise knot here. So an HR does things. MIR makes a mess. I see an XOR, which is good in the bitwise knot. Yeah, maybe there was a cleaner way to generate this stuff instead of doing this thing. But that's fine. It all gets cleaned up anyway, so I don't really care. Yeah, that XOR makes sense. And there should be an OR here. Yeah, okay. Fix RSA bugs for new bitwise operators. And then update binary op tests to add new bitwise operators. Okay. I think that's a pretty good place for today. I do need to study. It's already been an hour. Thank you all so much for watching my stream, especially if you're new here. Usually I stream for like 2 hours, but midterms week is kind of nuking me. Make sure you like the stream and sub to my channel if you haven't already. It really helps out with the algorithm. It helps get my content out to more people. While you're down there as well, make sure you join the Discord. That's the best place to get notified when I go live and to chat with me and the broader community outside of stream hours. And of course, make sure you connect with me on LinkedIn and add me on GitHub to stay up to date with what I'm doing. Yeah, it's time for me to study. I need to figure out how the time bounds on RMS scheduling works. Yeah, take care, y'all. Take it easy and have a wonderful rest of your day.